Hello guys, thank you so much for being with me in another artificial neural network tutorial video. In the previous video we talked about cost functions and said that this function is a criterion for measuring how bad the parameters are. We talked about a cost function multi-class SVM. We said that the goal is that the score of the correct class is at least one more than the score of the rest of the classes. Regarding the implementation, it is very simple. For example, suppose that the red number of the class score is correct. In this piece of code, the same formula that we talked about is included. We have considered the margin of the correct class to be 0 because we said that we should consider the rest of the classes. One flaw in this function is the cost. If we have data for which the cost function becomes 0 with a suitable w, then if we multiply w by any number, how does the cost function change? We multiply w by the input and get the scores. Now we solve that formula again for the same data. We see that the cost function becomes 0 again. So we have obtained an infinite number of w for which the cost function is equal to 0. Now we have to decide which of these w's to choose. The cost function makes no distinction between these w's. Yes, these w's have no difference for training data, but they work differently for new data. In the discussion of regularization, you saw that fluctuations become intense in large w's. So it is better to choose the smallest one among these w's. So it is better to consider an additional sentence in this regard, which we used to call regularization. These are w means a function of w. A function that if the values of w are low, the value of this function will also be low, and if the values of w are high, the value of this function will also be high. Now we have to minimize this whole relationship. By minimizing both parts of this relationship, we want to classify the data of the training set well and perform well on new data. Now there are different methods for this function Rw. We can add the square of the parameters together, which is L2 regularization. We can add the absolute values of the parameters together, which is L1 regularization. Another way is to use a combination of the two. It is called soft L1. Which is the same as L1. It is replaced by L2 only in the interval minus a half and positive a half. Another way to combine these two norms is to use elastic net. These are not very different from each other. It is only important not to allow the w's to become too large and thus increase the generalizability. Excuse me. Okay, I don't want to bore you, so I transfer the concepts of softmax and optimization methods to the next videos. Have a nice time.